Hello, everybody. My name is Joksan Flores, and today I'm going to be discussing the test and validate network automations for NetOps and DevOps environments. We've been talking about how we provide integration services into the automations and how we build orchestrations from end to end. How do we build those? But one of the most important things when we're making a change into an environment, regardless of whether that is an environment that is driven by legacy devices or whether it's actually infrastructure in a DevOps environment where we're making API calls to, is making sure that we're validating what we're proposing into the environment. One of the questions that was one of the previous questions in the last session was actually how do we validate input data from the forms? As you can see throughout the entire building of the automations, we're actually providing various validation methods along the way that we're allowing the user to validate whether there is data that's inputted by the user. We're actually validating formats. Some questions were brought up about naming conventions and so forth using regular expressions. We also have other abilities to validate actually API payloads as they come in when we go in the next session about exposure and how we're able to actually expose automations through API calls and not necessarily a form driven by the user, how we're able to do those things. I come from a network engineering background. I've been in many change windows. I figure a lot of people can probably relate. And I've been in many windows where we have the little text pad with our show commands that we're copying and pasting into the CLI, logging the session before and after the change, and then we go back and compare and perhaps do some comparing and contrast using some tool, or perhaps we're just spotting for mistakes. So one of those things that's really important, and that's a challenge in the current traditional environments, right? I've been in many troubleshooting windows after the fact where somebody missed something on the post checks and didn't realize that they actually broke something. So this is really important to automate. But this also happens on the DevOps environments, right? Let's not fool ourselves and think that everything is perfect when we're using API calls. So one of the things that we're going to focus and discuss is actually how we provide validation before and after, not only for CLI-driven environments, but also for API-driven environments when we're putting structured data in on a certain environment. In addition, we're going to do some compliance validation, and we're going to spend some time talking about how we enable users and practitioners to actually validate their configuration, whether they are a CLI-based configuration against the organizational policies, but also how we're able to actually accomplish that against structured data when it comes to an API call. And we're going to use an AWS security group, as indicated before, as the example for that. For this demo, we're going to spend a lot of time, like I said, focusing on testing and validation, so spending a little bit of time on our configuration manager tool that allows us to create compliance rules. And we're going to spend some time as well creating command templates for our CLI and legacy devices. And then we're going to spend some time as well showing you, in addition to what was shown during the build section, how do we actually plug those validations in so that we have an end-to-end process and we're not forgetting that we're just making changes to the environment, but we're actually validating those and making sure that we're putting things in that are actually not going to break stuff. So I'm going to move on to the demo now. So now what we can see here is our automation studio. As I was mentioning before, what I'm going to do is I'm going to actually start by creating some pre-check commands for our device that we're actually making changes to. On a previous session, we were actually talking about how we're making changes to separate disparate environments. In this case, we are making our data center device is a Cisco iOS device. So we're going to be making some pre and post changes. And what we're actually going to be doing is we're going to use our command template feature in order to do that. Like I was saying, this is a Cisco iOS device. So me, out of force of habit, every time I log into a Cisco iOS device, the first thing I do is I execute a show version. I want to know what I'm doing, what I'm dealing with, what software version, am I compliant, am I good with all those things. I'm also going to check on my interface's status, and I'm going to add a couple other commands just to make sure that I have some relevant checks for the changes that we're actually making. Another thing that we're doing with our change, whether this is actually a good network design or not, but we're actually going to make some distribution statements into our configuration. So I'm going to use my show IP protocols command, and I know that when I enable distribution, I get a redistribution enabled line into that output. So what I just did here is I am actually able to, when I execute those commands, I can execute some text-based rules by saying, hey, when I execute this command into this device, I want to make sure that this output shows up in that CLI. And that's also a very simple way that I can actually now remove a lot of the user errors when we're doing that spot check, right? So now trying to equate this from the analogy that I was using before, where we're all used to doing the little text pad or the Excel sheet with my show commands, and trying to avoid that I miss something on the post check so that I have to avoid that next maintenance window in the morning. I can actually be more stringent with my rules and saying, here, this is what I expect to see on the device. So I'm just going to program those rules beforehand.
How would you do that, or can you do that kind of thing if you're showing, say, an active routing table and your goal is to make sure the number of active routes is the same pre and post?
So we actually have the ability to, we're going to do it in here for audit purposes, but we also have additional features that allow us to actually compare the commands pre and post and actually show an intelligent diff that lets us know, hey, I actually changed prefixes.
Yeah.
And you can go very creative. And here you can actually have regex capability. So one of the things that I found myself doing in the past has been, I want to execute it. I want to bring up a BGP peering, and I want to make sure it's not idle after the fact. So I just bring it up, and I want to make sure I create a little regex that says, hey, it's not idle or 0. I'm actually getting some count of prefixes that's greater than 0, right? So 1, 2, 3, 10, 100. And that's the kind of stuff that I want to see. So you can take this and start taking it up a notch as you go and evolve through the journey and start learning more about those things and say, hey, okay, I'm going to start getting a little bit more intelligent about my validations and using more complex rules. In this case, we're actually pretty relevant to your example. We're actually going to do a show IP route command because we're actually changing routing as well as redistribution. And I'm injecting route, so I want to make sure that I actually see that route on the routing table. The automation, I don't know right now what that IP address is going to be. The automation does know. In the previous build section, there were data manipulations that were built already showing that we have certain variables that we will have access throughout the automation that the user is providing. And at the end, we'll show actually that's going to be API called. But we will have certain inputs that are available throughout the automation, and some of these IP addresses are known. So I can actually leverage it here within my command template and say, when I execute my show IP route, I expect to see this source IP address, whatever it is. I expect to see it on the routing table eventually. And to round this up a little bit, within the tool, I actually have the ability to test these commands. So I'm actually going to pull a device here that's actually federated throughout the automation tool. This device happens to be onboarded through our automation gateway, but I can actually test this against these devices. So I'm actually going to execute this show version. We know there's no rules. This is a simple show version, so I'm going to get a pass. And since we don't have any rules, I can see that my results are passed, right? On the other commands, I'm probably going to get some failed because we haven't made any changes into the network yet. So I'm just going to execute that and show that as well. And since it's a CLI device, it takes a second. But you see that I actually have the ability to do these things, and we see we'll get a little check mark. Throughout the automation, we actually call this and expose this. We're actually able to leverage those rules and those outputs and say, hey, did my command template pass? Did it fail? And so forth. Another thing that I want to call out is these command templates are not only exposed through our automation canvas, where we can plug it into the automation, but they're actually going to be exposed as discrete assets through an API. So these command templates could be called from a Postman collection if you so feel like, or it could be called from a pipeline. So now I'm going to actually go and plug that into my automation for the sake of continuity. So I'm going to go back into my workflow. So this workflow looks pretty similar to what was shown during the build section, but now we're adding a little bit more bits and pieces, and we're trying to complete the whole end-to-end picture. So I'm going to go and call my task. That's called run command template. And I'm going to add it into my workflow. And I'm going to fix that. And I'm going to plug it in here in the order that I want it. So I actually want to make sure that I execute this pre-change. And I will show you what that pre-change happens, what that change happens. So I'm going to call it pre-check. And now, because we said already, I'm going to call out my template because I just created it and it has a very static name. But for the rest of the variables, we're actually able to leverage, since I just connected the task, and during the build section, you kind of saw how it was shown that once we plug in the actual task, we get access to all the variable context of the entire automation. I'm actually able to use that for my command template. In here, I know that my source IP address that I want to validate against my routing table on the previous example is already on my form data, so I'm going to use that variable for that. And I need a device array, which is called out in here, and I know that that was created during the data manipulation section, so I'm going to go ahead and plug that in as well. So you can see that I now have the flexibility of making those changes and add those things very quickly. So I'm going to go and remove that piece of the flow because I want this to happen before the change. The changes actually happen on this task. So now I put my pre-check, but I want to make checks after the fact. So what I just did is I actually got to go ahead and clone that task and plug it in pretty quickly here because I'm lazy and I don't want to do this again. So I'm going to go ahead and do that. And I'm going to rename it and call it post check. So to address the question early and kind of round this up, go full circle, now that we have pre and post, we can actually inject another task that say, hey, can you compare these and show me the differences? So we can kind of plug, it's like, hey, we have my routes changed, right? I increased routes by 1, which is what I expect to see in this instance. I'm going to plug in my device array again. And now we have that piece added. So now we have a pretty complete picture of that pre and post check added into the automation. In order to go into the policy validation section, so I'm going to go ahead and start doing some golden configuration in my configuration manager application. When I go here, the first thing we can see, and it is worth stopping by here and actually showing that we have a federated list of devices in our inventory. You can see that this iOS device that I was actually referring to before is here, but we actually have a plethora of other devices, and these are just federated throughout the inventory. They could be CLI-based devices, or they could be coming in through an adapter and through an API-driven system. For this example, I have already, for my CLI device specifically, I have already created a golden configuration template that actually has a set of rules that apply to all my devices. So I have an inheritance model here where I have my blue configuration. It's global rules. There are a bunch of global parameters that I want to see on all my devices throughout my network. I also have some regional set of rules, and you can see how this starts building in. So my global had all the blue section on down to here to my LAN 28 where my NTP server is enforced. And now on my regional section, the golden config tree, I actually have some more advanced rules that have some management configurations, some static management routes, and some ACLs that I want to see on my device. The other thing you can note here is as I go through and go to my final node is we can build this inheritance model where I'm actually building my configuration in sections, and I can enforce and segregate this as needed. Another thing that you can note is that I actually have Jinja capabilities within this. So I can actually provide a list of access lists that I want to see on the device, whether they are for management, for SNMP restrictions, for NTP, what have you. I can actually build those and enforce those in a very flexible way. Let me go and grab my actual configuration that I want to see on my tree. And because we don't want to see, nobody wants to sit here and watch me type all this, we're going to leverage the greatest invention in the world, which is using the clipboard. And we're going to type that in. We're going to paste that into my tree. As you can see here, during the build section, you saw some of this. We actually had the capability of using Jinja like I was referring to before. And one of the things that are most important to note is that I'm actually able to use those same variables. Again, continuing with the theme of we have a set of variables throughout the automation that we can leverage. I'm actually able to use them throughout, whether it is in a command template or it is in a configuration or it's whether providing to an API call. So I got the ability to do all that. In addition, one thing that I added here that's not part of my particular service configuration is just because we're putting an OSPF configuration in, we want to make sure that we have a router ID assigned. And in this particular one, I'm relying on some regular expressions, right? So I'm going to save that, and that looks real good at this point. And we're going to go and actually contrast this on how we are actually able to do this same set of features and capability, but against an API-driven environment. In this specific example, an AWS security group.
How do you validate the data that you're putting in? You know, you've got a regex expression for router ID for OSPF. Is there a way to validate that to make sure that that's not been used in, you know, as a way to parse the routing table and say, you know, hey, if we're going to match our router ID to the loopback, I know that that's my expectation. Has this been used before? Is there a way to build data validation in like that so that you're not in a network where you have thousands of routers that you didn't suddenly just duplicate a router ID?
Well, we would probably rely on a source of truth, most likely, where we can actually pull that information and actually pass it as a variable. So instead of doing a regular expression where it's more generic validation, like I just did, I could actually pass it a variable and say, hey, this specific router that I'm dealing with maps into this router ID, and that's what I want to see on this particular device. Does that make sense?
Got it.
If we wanted to build more advanced checks, then that goes into actual building of the automation. There are a couple ways of scanning that cat. Let's say that.
So Netbox or my
Yeah.
ITAM, I might draw from that source via API to fill that data in if I want that kind of validation.
If I have, I have completely have the ability to pull Netbox for saying, hey, give me the loopback 0, for example, address for this particular device, and I want to use that and validate it against my router ID of OSPF and MPLS for that, right? Just for a real use case example.
Yeah,
I could totally do that.
Yeah, great, thank you.
No problem. Well, okay, so we're going to continue and do this, but we're actually, in this go around, we're actually going to create this compliance rule against a JSON node. And this is really cool to actually demonstrate and show, because compliance validation against CLI-based devices is something that we've been doing for a while, right? It's something that we've presented before, but now we're actually able to showcase how we're able to execute these compliance rules against a data structured environment like an AWS security group. And essentially what I'm trying to do here, my intent is to show that when I submit a security group rule change, I want to see this output be stringent, and I want to make sure that I'm not making the wrong call into the AWS security group and enabling, perhaps opening a hole for the wrong application. Another thing to note, again, continuing with the same theme, I'm actually able to, in this compliance, I'm actually able to insert variables that are known within the workflow. So in this case, I'm using the port because it's what AWS security group needs in the actual payload. And in the data manipulation section, you saw how we actually had to manipulate the IP address for the source and actually tack on a CIDR format to it, because that is what AWS needs. So I already had that variable that I can actually use and say, hey, when we validate what our security group payload looks like, I want to make sure that it has that source IP address with CIDR on it. So we actually have those cool abilities to do things like that for our JSON compliance. So okay, so now that we have created those two, we're actually going to go back into our canvas and actually plug those in and kind of try and finish the testing and validation section, and making sure that we have a workable automation that's validating itself and doing all those cool things. For our security group validation, we actually have pre-populated that here. So we have it after the update security group piece, just for the sake of time. And I am going to go and add the task just to show how simple it is to actually populate those for the CLI device. One of the things that I want to also highlight here is that we have the ability to actually execute these changes proactively. As you can see here, what I'm actually doing is injecting the run config compliance prior to the change to the device. So I want to make sure that instead of being reactive and saying, I created this config, I pushed it into the device, and now it doesn't comply with my network standards, then I'm actually doing that prior to the change and saying, it's my proposed configuration valid, and should I be actually pushing that, or should I actually stop and perhaps take some other action? So we're actually going to go ahead and do that. And this actually run config compliance task actually runs against the device name. So throughout the platform, it's already well known which rules apply to that device, because the device was already previously associated with those rules. So we're going to go ahead and pass that into that task. I'm, again, leveraging the variables that are exposed throughout the automation. And I'm going to pass it that config that we just rendered as well. And we're going to complete that with that. What I have been highlighted throughout the whole demonstration is how we have the ability to validate data at different levels, whether it is validating user input, or, for example, one of the things that I want to discuss as well is at the very top, it's the track where we're making changes to actually firewall rules through the Panorama API. And we actually can see that here, that we have a pre-check and post-check. What we're actually doing is executing an API against Panorama prior to the change, making sure that the firewall rule doesn't exist prior to applying it. And we could do some other more evolved logic saying, if it exists already, perhaps we need to take a stop, or we don't submit it again, or we do something, we notify a user. And we're actually validating after the fact, making sure that it does exist truly. In the center, as we go through the security group, this piece is actually a little bit more involved, because what we're doing is we're integrating with a GitLab pipeline here by pushing a commit into GitLab. And what we're doing with that is, once we make a commit into GitLab, that will launch a pipeline that's executing unit tests in the infrastructure environments through a DevOps mode. So if you're collaborating from a network operations standpoint, collaborating with the DevOps team, you could say, I'm going to go and trigger your pipeline. Your pipeline, it's going to do its thing. It's going to do whatever you programmed it to do. You unit test on your applications, so your infrastructure in the cloud and so forth. And then that pipeline will call us back, and you will see that once the demo is launched, we'll call Itential Automation Platform back in order to continue the rest of the flow. Then we can execute our security group update as programmed during the build section and actually run that compliance that we just discussed and showed up. And at the bottom, to round it up, we already kind of discussed this a little bit, but we also have our full change to our data center device, where we're actually executing pre and post checks and actually running compliance against our proposed configuration.
And this is John Herbert. What happens when one of these changes fails?
So in this case, obviously the demo has been pretty prescriptive, so we already know what's going to happen. We also have the ability to plug in things like evaluations and provide logic. So I'm going to do this dynamically here. So I can, in theory, just say, I'm going to connect this task here, and if it fails, I could do something else. So I actually have the ability to provide various levels of logics and checks, and I can actually say, I want to revert back and say, I want to retry this a couple times, and if it fails again, then I'll notify an operator or the NOC or what have you. That answer the question?
Yeah, I think so. Thank you.
Well, I was thinking more along the lines of it fails in a way I didn't anticipate. So a random box, anyone on that thing tries to do its thing and fails, what happens?
So I have error task is typically what we propagate. So we have a couple ways of propagating. Either on purpose, we propagate failures, which we can address with logic. If I'm going to hit an API and, for example, I get some connectivity issues, I have a way to address error. And then, for example, here, like I was providing, let's say that the create security post rule, for example, fails. I lose connectivity to Panorama. I can actually do this here, where I could say, okay, if that happens, I'm going to go back and start from the beginning and do my transformation again, execute my pre-checks, and try that again. And we actually have pretty evolved features where we can actually create some retry logic that says you're going to retry this 3 times every 30 seconds. If it fails 3 times, I am done. I'm not going to try this again. Perhaps we just roll back the whole automation or notify somebody to go and take some manual action.
So I do have to create a failure workflow for anywhere I expect to see a failure. And what does happen if one of these along the ways fails and doesn't work that I didn't anticipate and I don't create that thing?
Well, it depends on how that's addressed, right? It depends on how the automation is built. At the beginning, if we error and we didn't account for that error, it just pauses right there, right? So we just pause, and we have the ability to, the one thing that you have the ability to do also as an operator of the automation, you also have the ability to go and retry that manually. So let's say that you built your automation today, you didn't account for perhaps a connectivity issue or something like that. Your task will pause, and it'll stop the rest of the automation from occurring. What you can do is actually manually go back and revert that job and say, I want to retry this again manually. But now you learn your lesson, and hopefully next time you come and execute, before that, you go and address your logic.
Okay. So in order to recover, I've got to have a failure mode off every task.
Not every task. Not every task will fail, right? There are certain tasks that are just manipulation that you know that you tested enough. But when you're talking to APIs and things like that, there's always the chance that connectivity will be lost, that you use some post-body schema that doesn't correspond. So probably some error validation is probably warranted.
Yeah, stuff happens.
Yes, it happens.